Hello and welcome to this short video about interpreting histograms. I'm hoping that you've already watched another video, perhaps my other video, about drawing histograms, so we already have an idea about how histograms work. The key thing that we need to remember, exactly the same as when we're drawing them, is that the area of a bar tells me the frequency, not just the height of the bar. So if we look at part A here, we need to estimate the number of cyclists who rode for 30 kilometres or less. And in this particular one, they've told me the frequency density. We'll look at an example in a minute where they haven't given me the frequency density. But because they have given me the frequency density, this is actually very straightforward to do. If we look at the first bar there, the width is 20, and the height, using the frequency density they've given me, is 4. So for that first bar there, all I'm going to do is 20 times 4 is 80. So I know that represents 80 people. Similarly, the second bar has a width of 10 and a height of 10. So that's going to give me 100 people. 10 times 10. So the answer to part A there is 180 people. And to work out the mean, I'm going to need to do what I always do for group data. I'm going to need to know how many people there are in each of those bars to start with. We'll just make ourselves a little table. So we've got 0 to 20, 20 to 30, 30 to 57, and 57 to 70, and 70 to 90. And we'd already worked out that the frequencies here are 80 and 100. And using the same method, well, I'm sure you can see that we get 54, 117 and then 120. Then as we would for any grouped data, we're going to need the midpoints. So that's going to be 10, 25, 43.5, 63.5 and 80. We multiply those across. So 10 times 80, for example, to give me 800, 2,500, 2,349, 7,429.5 and 9,600. And we're going to need the total frequencies, the total number of riders. So all we're going to do is add up all those frequencies to get 471. So my estimate of the mean is 9,600 divided by 471, so it's about 48 kilometres. So sometimes they give us a question like this, and if you notice on the frequency density scale, they've not given us any numbers. We don't know what the frequency density is. When they do this, they're always going to need to give you at least one bit of information. Very often that'll be in a table, but here they've just given it as a bit of writing. 92 people could hold their breath for 0 to 20 seconds. So we know that this bar here is worth 92 people. Now, if you remember, the frequency density is equal to frequency divided by class width. So I know that the frequency is 92 and the class width is 20, and 92 divided by 20 is 4.6. And this is the clever bit. We know that up to there has to be 4.6. So what we do is we look at the number of squares, and that lets me determine the scale. If these boxes were going up in ones, that would be 2.3, but it's not 2.3, we need 4.6. So these boxes must be going up in twos. So each of the little squares going up is worth 0.2. So we can then fill in our frequency density, and then the question becomes very similar to the one we looked at a minute ago. Here, we want to know how many people could hold their breath for between 20 and 30 seconds. Well, I know that the class width is 10. Going up there, that's 12, 14.4. So it's going to be 10 times 14.4, which is 144 people. And then obviously if it went on to ask you something like find the mean, you'd be able to do the same as we did a minute ago. Okay, so as I say, sometimes I'll give you a question like this. Notice there's no frequency density given. They've given us some numbers in the table. The first thing I need to do is start matching things up. So this here is the same as that, 200 to 250. So that bar is worth 25. So as we did a minute ago, if you think about the frequency density, it's going to be 25 over 50, because the class width is 50 from 200 to 250, which is 0.5. So I know that up to there is 0.5. So each of these big boxes is 0.1. Now to look at finding that frequency, like we need to up here, the class width is 150. The frequency density is 0.3. So I'm just going to do 150 times 0.3, which is 45. So to finish this off, if we think about frequency densities, this is going to be 20 divided by 100, so 0.2. This is going to be 60 divided by 100, so 0.6. And this one is going to be 35 divided by 50, which is 0.7. So we'll just quickly draw those on. We go from 0 to 100. It's going up 0.2. It's going from 100 to 200 and up to 0.6. And then it is going from 400 to 450 and going up 0.7. I'll just put another question here. How many people spent more than £420? And of course this is really hard because £420 isn't one of the boundaries. It's in the middle of the 400 to 450. But the good news is we can use the histogram to help. Now 420 is there. So I know that all of this bit up here is bigger than 420. So my class width is 30. My frequency density is 0.7. So all I'm going to do is multiply those together to get 21. So 21 people spent more than £420. So we can split it up. We can split up the bars and use the same frequency densities. I hope that helps. Thanks very much.